Ladies and gentlemen, girls and boys, may I have your attention, please? Are you ready to engage in a mind-blowing experience and hear talks about life, technology, entertainment, and business? The next episode of Hipther Talks starts in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, go.
Hello everyone, good day, good morning, good evening, wherever you are located. We are happy to know that you're tuning in to hear our podcast. Today we're having Felix Negoiță from CryptoDATA Romania. He's the head of AI in this company. And first of all, welcome Felix. Second of all, tell us a little bit about yourself, about the company. Take a spin and make yourself a short intro.
Yeah, thank you, Alex. Thank you so much for having me. It's great that we get the opportunity to finally discuss some of our favorite topics a little bit more at length in this friendly virtual fireside chat-like environment. To everyone out there either listening or watching this podcast, my name is Felix. I'm the head of artificial intelligence at a startup in Romania called CryptoDATA. Currently, I'm working on a AI-powered decision-making helping application that we will be launching at the end of March. We're very happy about that. It's called Decision Point, and it's based on a lot of NLP. And I have a background of mostly data engineering, data science, and software engineering. So I'm looking forward to seeing what you have prepared in terms of talking points for our discussion today. And I think without further ado, let's get started, dive right into the topic, and hit me with some hard ones.
Okay, I do have prepared some, not necessarily hard ones, but some strong questions. For today, we've prepared a list of questions, a list of curiosities, and or fun facts from the big data and AI world. Things that people are curious about, things that people are sure that things are going on one way, and we want to hear from experts like you, from people that work on a daily basis in this world. We want to hear that if things are true or are not true. We want to know which statements are myths and which are facts. We want to know if everyone's curiosities are aligned with the actual trend, or it's just something out of a storybox.
Yeah.
So today's podcast is called Debunking Big Data and AI Myths, Curiosities, and Fun Facts. Let's start with number 8 on the list.
Okay, fair enough.
Truth or myth? Is access to big data or having big data working on something a guarantee to have ensured a better decision-making process than humans?
Yeah, very interesting topic you've touched on, Alex. It's not a guarantee. So let me give you the answers straight up first, and then we can talk around the subjects a little bit more. It's not a guarantee. However, it helps a lot. Now, you've mentioned decision making specifically. Every time we want to make decisions based on the data that we have, we make some assumptions. Now, usually when people talk about big data, there's two types of enormous amounts of data that you can have available to you. There's enormous amounts of data that you can have for a certain point in time, from very many users or very many machines in the case of an IoT environment, or very many endpoints, or you can have historical data. So you have data that goes far into the past. When you have historical data, you're making the assumption that things will behave in the present as they have behaved in the past. And if that assumption is correct, then yes, big data will 100% help your decision-making process and you'll get amazing forecasts out of it. However, data scientists need to really consider, or businesses really need to consider, whether or not that assumption is correct. It may not be. So for example, a lot of people are trying to make various stock market predictions based on historical data. But I think the assumptions that the stock market will behave exactly the same way in the future as it have fluctuated, so behaved in the past, is not a correct assumption, right? So yes, obviously big data does help, but the most important thing is whether or not the sheer volume of data works with or against the assumptions that you make. So I hope I answered your question.
Yeah, but in the same time, some other questions popped up, and I'm sure that it would be really nice for our viewers to have a little bit more light on the big data term, generally and very short, because this is a subject that can be talked upon like days. In a nutshell, what is big data?
So I would say big data is any amount of data that does not comfortably sit in a single database. So if you have a database that you're trying to query and you can't get results in a timely manner or in an expected time frame, and then you start having to split your data in several databases in the cloud, in several data lakes and data warehouses and other places like that. And it's not manageable by one single system or piece of software, then you're pretty much into the realm of big data.
Okay. Now, sticking to big data, let's have another one. Big data is the universal solution. What do you think about this? Is big data currently a solution to, well, anything?
It is a solution, but not the universal solution. So it is, you might be trying to find patterns and there's not enough data for you, but you have some sort of human intuition or some sort of human level real world knowledge or real world observations that are showing that there's some sort of pattern there that you're trying to discover, or there's some sort of way that you can get value out of it, like collaborative filtering, which is the algorithm that social media uses to get to know us and recommend the things that we like, right? So in that case, yeah, it's definitely a solution because it's definitely a pattern. If you like a certain show on Netflix, there's a high chance you will like what other people who like that show also liked, right? That kind of thing. Mm-hmm. But it's definitely at the same time not a universal solution, because you have to imagine that there is this storage data layer. And on top of it, there is the compute layer, which is what you do with the data. So this on the compute layer is the part where your algorithm comes in, your machine learning model, your application level, business logic, and all sorts of things like that. If your algorithm is faulty, no amount of data will fix that. Right? So if what you're trying to do either makes wrong assumptions, like I've mentioned at our previous point, or is thought about a very specific instance and does not generalize very well, or any number of other things, or it simply has bugs, or it has some human bias or some human error in it, or there's cases they haven't treated, right? No amount of data will be able to fix these things. That's why we can't say that big data is the universal solution. You can have as much data as you want, and on top of it come with faulty logic. That's gonna ruin everything.
Okay, so you kind of stepped into the next one. There's this common belief that more data is better, and basically you just answered that meaning that more data is not necessarily better if the computing layer is faulted. But another one, still going with big data. Do you have to be an engineer to handle big data? Or are there any kind of aiding software or I don't know, algorithms or programs that are meant for ordinary people to be able to handle big data?
There are. So there definitely are, I think mostly there's software as a service type products, right? SaaS. And it's part of what I'm building right now. And it's also a software as a service where you come to a non-engineer user through a more or less friendly interface, and you give them a very specific set of operations or options for them to explore on top of the big data that you have in your data lake in the backend. So there definitely are such services. Now it depends. It depends what you want to do, if it's your data or not. And then there's the question of, do I just want simple reports? And if I do that, a simple reporting or a general purpose analysis, like how much of item X have I sold in what time frame and so on and so forth. And this is a problem that you can very easily solve with software as a service or just all sorts of software products. You as a non-engineer, you just go ahead, or as a company, you go ahead, you purchase them, you put them on top of your data, and they show you, like, in a UI with graphs and with tables and with whatever it is you want. They show you results to more or less general non-specific queries. That's one key case. However, if again it's your data and you're trying to find out something very specific, you're going to 100% need engineers to do it for you, to be able to handle it for you. One abstraction is you have to handle the infrastructure for it. So there's no single database. If you don't have your data in the database, somebody comes and writes a very simple 5 lines of code and you have your answers and there you go. So you have to have an infrastructure, right? Maybe you're ingesting data all the time. So new data comes in and you have to integrate that, and you have to clean your data because it doesn't come in right. And then you have like intermediate states for the data, and you keep them in a data lake or a data store. And then you have to have a transformation processing step. And then you have to, keep obviously the process, we call it gold data. You have to keep it somewhere else. And then from there on, some other software engineers or the same software engineers have to come and build specific machine learning models for your problem, specific software for your problem. So I would say it very much depends. It very much depends on on your use case. You can kind of do it both ways, I think, but you're kind of limited in what you can do with existing products.
So basically, you don't have to be an engineer to handle big data, but you need engineers to create the instruments you need as a non-engineer to handle big data.
100%. Yeah,
okay,
absolutely.
So engineers are our friends then.
yeah, absolutely. You're 100% in the, even when when you purchase a software as a service, or you purchase any piece of software, whether it's an analysis tool, a visualization tool, any sort of tools, they have to have a lot of engineers in the back end, making sure that everything works, everything is integrated, and so on and so forth. So absolutely, yeah.
Okay. Skipping from one to another, you mentioned machine learning. There is this urban myth going on that intelligent machines learn on their own.
Right. What do you mean by on their own?
Well, the general belief is that once you teach a machine how to learn, they will learn on their own, and they will automatically develop and learn all kind of other habits.
So they do learn on their own to the extent that once you told it what to do with your data and how to do it, the machine, there's a slight difference between machine learning algorithm and machine learning model. The machine learning algorithm is how you tell the machine how to learn, so to say, and the model is the result of that learning that you can then later pick up and use, right? So once you pointed the machine to the data and you have given it a specific algorithm, which you have to choose for the problem, mind you. So you have to choose very specific algorithms for very specific problems. Once that happens, it takes time. There's what we call in AI a training step that happens in epochs, where the algorithm goes through your data and it does learn by itself. So it creates the model by itself. By itself meaning you can just take your hands off your laptop. From that point on, you just wait for it to crunch the data, right? And once it has finished crunching the data and doing what it has to do, we can talk about that separately, exactly what it does there. Once it has finished, you have a model, which is a result that you can then apply new data on, and it will say something like, you will put labels on your data, or it will try to make a prediction or something like that, right? A recommendation, a prediction, or label, or other things. This is what usually happens with supervised and unsupervised learning. There's also the case of reinforcement learning, which is very popular among the video game community, first and foremost. And it makes headlines sometimes because from time to time it defeats a famous chess player or a famous Go player, right? And then people, and that obviously gets very, very present in the media, and people start hyping it all up. And what happens there is, it was interesting in the case of AlphaGo, who defeated the world champion at Go, which is like chess, but much more complicated. They didn't tell it the rules of the game. They just showed it a bunch of examples of the game and let it infer the rules by itself. That was a different, slightly different approach and a slightly different step. But even in the case of reinforcement learning, we know how it learns. You have to point it to the data, and then you have to give it an algorithm. So you have to give it something to run the data on. And then, the training process is just the time it takes for the algorithm to run on top of your data to produce your model.
Mm-hmm. So let's take a totally random use case just to understand the notion of self-learning. Let's take the example of video footage from CCTV from an intersection, right? There are three directions a man could drive or walk. The first one leads to a low-cost supermarket, the next one goes to a medium-range cost supermarket, and the next one, the third one goes to a high-end shopping mall, for example. If we teach basically, if we track people, right, which ones are going to the left, to the middle, and to the right, and then we teach the algorithm that left means cheap, straightforward means medium, and the right turn means expensive. Afterwards, if we teach the algorithm the neighborhood that people are coming from, could they learn by themselves for example, how to classify neighborhoods depending on where people are going?
Yes. So the answer is yes, but not the same. I would say not the same algorithm. You have to go with a different step, and it's like pieces of Legos. You have to keep building. If you want a system to become more complex and do more things, you have to keep adding things, right? Keep building with it, keep playing with it. So it's probably not going to be the same. It's probably not going to be the same model, because if you want a reinforcement learning model that learns how to optimize a cost function, and if you want to classify, you can get if you have the data, then you can get it with the neighborhoods like you described, and feed it to a different algorithm, a classification algorithm, and that algorithm will be able to make the classification for you. And then what happens is you can make a sort of a pipeline for AI, which is called ensemble learning, where you have the outputs from one model that become inputs to another model. And this is how much more complex things are built, right? You have multiple models and they feed data into one another.
Yes, basically.
But it's not the same model.
It's basically switching from Lego for kids to Lego for grown-ups.
Yeah, so Lego for engineers. Yeah,
you keep on adding.
I still do Legos, so.
Yeah, I think most of us do.
Yeah, I think most of us do, yeah.
So, after all this, we are approaching another thing that is a common. I think this one we can say for sure is not a myth, because I personally know it's true, but I want to hear a couple of arguments on why is this true. And the statement goes like this: AI systems are only as good as the data they are fed.
Right, this is a tough one. So yes, also no.
Okay.
Yeah. Yes, also no. So let's take the yes part, right?
Okay.
Let's take the yes part. There is a principle called garbage in, garbage out.
Okay.
The data is what comes in. You feed in garbage, you're gonna receive something that's garbage. So the data has to be relevant to the problem that you're trying to solve with AI. First and foremost, it may not be, but it has to be relevant, and then it has to be properly sampled. That's another issue that maybe people are not thinking about all the time. So let's say you want to find out about some sort of purchasing trends in Romania. I'll give you an example, in any country, right? So what do you want to do? What do you have to do? You have to go ask people, questionnaire style, right? Have to gather data points from people, questionnaire style. You got to go and ask them whatever it is that you're trying to find out about purchasing trends. So here's what happens. If you go and ask only very high income people exclusively, or very low income people exclusively, your entire data set is going to be skewed one way or another. It's not properly sampled. You have to go ask high income people, medium income people, low income people.
Okay.
So then your data gets skewed one way or another. You didn't properly sample it to your problem. Your problem is you want to find out purchasing trends in the entire country. If you only sample from a specific group of people, and then you obviously add AI on top of it, it's going to make decisions, predictions, whatever, that are relevant only for or are descriptive only of the people where you sampled your data from. This is an example of a problem. So,
okay, but how can you ensure that you have the data sampling covered for all categories?
Well, this is the job of data engineers and data scientists or the different researchers that are working at a problem. So the data engineering process is, I tell people this all the time when we talk about building machine learning and AI systems. Data engineering is maybe 90% of the problem. It's 90% of the effort that we have to make. The part where you train your ML model, the part that's very hyped about in the news, is like the final 10% of it. But you have to have this pipeline of highly skilled humans that we call data scientists and data engineers to ensure all of these things and more for you. There's no other way. So they need to ensure that the data set is representative of your problem. They need to be sure that your data is not skewed, one way or another. So it's not representative only of certain specific cases, right? It should be, depending on your problem, as general as possible. They also need to make sure that it's not full of noise. Right? So they need to filter out the data points that are not valid or not representative, or they're just not useful in any way, right? They're the garbage, let's say. So all of these are part of the yes column. Yes, your system is gonna be as good as what you put in it when you train your model, if it's a machine learning system, right? But there's also no. So let me give you an example. In a very, very fascinating book I read.
Please do. I'm so curious about this.
So there's this example in a book. It's called Calling Bullshit, and it's written by professors at, I believe, maybe I'm mistaken, they're university professors in the US, I believe at the University of Washington, but I'm sure somebody will correct me in the comment sections if I'm wrong. But the title is correct, and they give this very funny example in their work. They say some data scientists took the data from athletes running the, I think, 500-meter dash at the Olympics. Athletes running a certain fixed number of meters, right? And they took this data from different instances of the Olympics in the past. And they said, oh, here's something interesting. The time it takes our athletes to run the 500 meters or whatever it was is getting shorter and shorter. So our athletes are actually getting better with each upcoming generation. They're able to train themselves to run faster, basically, right? So they finish the 500-meter dash in a shorter number of seconds, right? Small number of seconds. So what did they do? So they said, let's build a model that tries to predict how fast they'll run at the next Olympics. You have all the data from the past, right? And they did that, but they built a linear regression model. So if you have, imagine the axis, you have the years and you have the number of seconds, right? So it goes from, because in the past it used to be the highest value, it goes like this, and it comes, because it's linear, it comes all the way down like this. Now, what's the problem with that? The problem with that is eventually, if you go further enough, it will overcome the axis. So we will get into the negative values. So their model predicted that by 2040 something, athletes will finish the 500 meter dash in -4 seconds or something like that. Right? So you can have the data, and the data is accurate and good and representative and not noisy, but you just put an incredibly stupid algorithm on top of it, stupid from the point of view of your problem, right? And you modeled something that's garbage.
Hey, maybe this would be the secret to teleportation.
yeah. Maybe, they'll figure something interesting out, right? So that can 100% happens. You have the data, you have everything you need. You choose the wrong algorithm, or the right algorithm doesn't exist. That's also the case. So we have a very, contrary to popular opinion or contrary to popular media, we have a very limited number of types of problems that can be successfully solved with AI, with machine learning, presently, right, at our disposal currently. So yeah, there's also the yes and the no. This has been a longer discussion.
I never thought of it from this point of view, and it actually makes sense. But now a little bit of clarification, please, on the differences between, or if there are any differences between machine learning and AI, artificial intelligence.
Yes, there are differences on the academic discussion level. So AI began roughly in the 1950s, and it was used to describe any process through which a machine can make an intelligent decision. Now, what intelligence is and what intelligence decision means is something of a philosophical discussion in itself, but they built a lot of different algorithms that are not machine learning algorithms to be able to make more or less these intelligent decisions, right? To be able to control all sorts of systems. So you have expert systems which are based on fuzzy logic. They were also considered artificial intelligence. But then machine learning took over, and for the point of view of the general public, AI is always machine learning. So we can say that they're the same thing. From the point of view of the academic discussion and the history of it, AI comprises some other methods, let's say, that are not machine learning, like expert fuzzy systems, for example. But they're, to my knowledge, at least, they're not popular anymore, because we have seen much better results with machine learning.
Okay, now is AI and or machine learning, is it approaching human intelligence? Are we on that road?
Oh, absolutely not. Absolutely not. Now, this has been a question ever since Garry Kasparov was defeated. People started to freak out about this when Kasparov was defeated by IBM's DeepMind. The algorithm existed almost 40 or 50 years before Kasparov was defeated. His defeat was by no means an achievement for AI. People don't know this. It was an achievement for processors. The algorithm is very, very basic. The algorithm that beat Kasparov is a simple look-ahead algorithm, which is the same as trying to solve your Sudoku board without understanding anything about strategy and just trying every possible combination. So what happened when Kasparov played against DeepMind was that the processor was much better, which meant it can look ahead more extensively. The method itself was very old, and it was the same method they came up with in the 50s. So what happened was that, you know, people envisioned that this was a huge step for machines because machines now got much smarter. They didn't. They were as smart as they were 50 years before. The processing just got faster because processors got better. However, people forget that IBM's DeepMind will have continued to play chess even if the building caught fire. Now, what am I trying to say is there's absolutely not even an intention in the AI community to build something close to general intelligence. So general intelligence, or what humans have, is first of all, a lot of real world knowledge, or knowledge about the real world, a lot of common sense. All of these impossible to program for obvious reasons, and a lot of processing and computing power inside of our biological brains that we are not aware of, and that we have no idea how it works, basically. So the problem of consciousness is an open interdisciplinary problem for psychology and for neurosciences, for philosophy. Nobody even comes close to bringing up a satisfying definition, right? Because the scientific community argues even about the definition of what consciousness is. And general intelligence implies, first and foremost, I believe, common sense about real world knowledge, right? And this is impossible to put into a machine. And I say impossible fairly confidently. It's not, I think, a problem of, but hardware will get better. Absolutely, hardware will get better. It always does, right? But becoming faster and faster in something will not mean that you can pass to something that's on an entirely superior level, right? So the kind of intelligence that humans have, and the kind of decision making that they do, even with something as seemingly banal as language and speaking and uttering creative things, is something that we have not fully explored, and is something that we have, but almost no idea the workings of. So, no. Sorry to disappoint.
Okay, now something a little bit related to this. Super intelligent computers will become better than humans at doing anything we can do. It's a tad related, but basically it's not the same thing. What's your take on this?
Yeah, no, I understand. I understand the difference. So computers can become better, and even now are better than we are at certain things. I think it's very hard for most people to beat a good chess playing algorithm, even a bad one. I think even a bad chess playing algorithm is still difficult to beat for almost the entirety of chess aware human individuals. So they can become better at us than doing certain things, and they already have, which means that the future will probably, the future will probably be an extensive cooperation between man and machines algorithms. So you have these recommendation engines in social media and other services platforms. They are better than even we are at trying to come up with things we might like, right? However, better than everything is 100% impossible. We think about this. You have to give a computer thousands of images of cats for it to confidently be able to recognize cats in new pictures that it hasn't seen, right? And if the new pictures are maybe depictions of cats, right, works of art, or if the cat is behind some object, or the shadow is, I don't know, different than what it has seen before, it will fail most of the time. Or if the cat is a small dog, it will mislabel it and say it's a cat. You have to show a child what a cat is once. That's it. And it will even be able to recognize the representation of a cat, let alone all possible cats in the real world, right? You will even recognize a cat in cartoons and a cat in paintings or in YouTube videos, and it will understand that that's not the cat per se, but it's meant to represent cats. So our level of intelligence is so deep and so layered, and scientists are so at the very beginning of understanding its workings, that I simply cannot fathom how it would be possible to code it from a software perspective, irregardless of the hardware that powers the machine.
Okay, so we're safe.
Yes,
Now,
we're safe. If something goes wrong, we'll kill it with fire.
Yeah. But at least the computer will keep on playing chess even if the building is on fire. So.
Yeah. Exactly.
Yeah, that's a good way to trap one, just in case.
Yeah.
Now we don't have that much time left, and we do have some on-point statements that we have to tackle. First one, AI can be 100% objective.
No.
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 Okay.
Definitely not.
What if the data is objective?
The data can be objective, but you fed the data, you fed it to an algorithm, and in doing so, you made some assumptions.
Okay.
What I was talking about earlier. The chance that the assumptions are universal and objective and have so you can have bias in assumptions as well, not just in the data or the algorithm. There's no way the resulting product is 100% objective. No way.
Okay. AI can read your mind.
What do you mean?
Well, basically, I think that this is referring to next level predictions.
It could make predictions better than we could, even for ourselves. And I think it already does. You've probably spoken to your wife or a loved one about something and you immediately saw an ad about it on social media, or you've seen an episode of some show and then the streaming platform, who shall remain nameless, recommended something and then you were like, oh my God, this is exactly what I wanted to see, right? We've all had these freaky moments.
Yeah.
It can, but read your mind. Humans are very unpredictable. You are predictable maybe in regards to the shows you watch, maybe some of the things you like, but humans, there's entire literature devoted to lamenting the fact that we don't act rationally in our lives. There's so much literature on this, that we're too emotional, and the emotional decisions and this and that. So it might, for some things, if you refer to some specific predictions, but
Okay.
you probably can't read your wife's mind.
I don't want to get there. But speaking of this particular relationship, I noticed a trend. Take Siri, Alexa, Cortana, they're female. Most AI bots are female.
I wondered about that. I wondered about that too. I don't know. I don't know. Maybe it's a cultural thing. Maybe we are culturally used to the idea of women helping us and looking after us. I don't know. It's obviously that historically it has been the case. Women used to be the keepers of the household, devoted mothers, and then you would have nannies and housemaids and cooks and so on. Maybe it's a cultural component to it. It's very interesting. I don't know, but I have noticed. Yeah, I was noticed that too. The female version of Siri is there's a male version of Siri too, but the female version is way more popular. I don't personally know anyone who has a male Siri. I don't know.
Does it maybe have to do something with the fact that I'm not remembering the number exactly, but I think 80 or 85% of AI engineers are male?
I haven't really thought of that. It's definitely the case that software engineering is still a male-dominated field, but the trend is declining. There's an upward growth regarding the number of women in tech, in STEM in general, and then particularly in software engineering. And you can view AI as just like another sub-branch of software engineering. So it could be that that's the case, and there's some sort of male bias there, but that's slowly starting to correct itself, I think, as more and more young women are being encouraged to pursue STEM specifically, and then to pursue software engineering. So very interesting. Yeah, I'll look into it.
For thought for the next conference.
yeah, definitely.
Well, I've got two more. AI means huge budgets, and AI will kill jobs.
Okay.
These are tough ones, but I think we can handle them.
Yeah, no worries. Right. AI on big data is a huge budget, 100%. However, you don't have to. You can do machine learning on data sets that are very manageable and can get business intelligence out of it, can get valuable information out of it, can have maybe a decent knowledge discovery process set up by your company for the price of 2 software engineers or 1 maybe. So it doesn't have to be, but at scale, running AI on big data is very, very expensive. Storage is cheap on the cloud, but compute is expensive on the cloud. So there's that. And the second one was, can you please remind me, what was the second one?
Yeah, sure. AI is killing jobs. The fright that AI will take over the jobs.
Yes, it will kill some jobs. To my knowledge, it hasn't yet. I think it will. all technology kills some jobs. All important, I want to say revolutionary, but all, because that's for the historians to decide. Maybe it's a fad and we'll forget about it. But all important technology changes the job market. It kills some jobs, but it also creates jobs. Now, there's an issue with that in the case of AI specifically. The issue is there's going to be a very high cognitive difference between the jobs that AI kills and the jobs that it creates. So if you have autonomous driving trucks and they kill the job of truck drivers, and obviously they create the job of ML engineers for autonomous driving systems, there is this cognitive difference between what the requirements are for driving a truck and what the requirements are for becoming an ML engineer. And maybe as a society we'll have to come to grapple with the problem of how do we help integrate former truck drivers in the new job markets. How difficult will that be, and so on. So in the case of AI, or in the case of software specifically, there is this problem between the jobs that are being created and the jobs that were lost, let's say. But it's normal, and it's not, I think people tend to over-exaggerate a little bit in the terms of AI, because they're maybe a bit afraid of the technology. The ATM killed jobs. The automobile obviously killed jobs. Think of all you had to do to keep a horse alive. And all of that. So this is the natural course of history, a natural course of events. But from what we can see so far, where AI systems have been successfully integrated into certain industries, they have not managed to replace humans. They're just extra tools that are helping relieve some burden of the human workers and working alongside them. So it's 100% going to be a much easier transition than people expect, I think.
Hopefully that will be the case. Personally, I'm really open to this, and I see this as an opportunity. Basically, if we stay to think back, a huge number of tech developments killed jobs, like as you said, the automobile, the email. You don't have to go to the post office anymore. But in the same time, it's killing jobs that, if we can program something to do that job, it means that the job itself is obsolete at the moment. And in the same time, it creates opportunities to new jobs and to help us as humans to advance. So this would be for today. Thank you very much, Felix. Thank you everyone for tuning in on whichever platform you are watching or listening to us. Stay tuned. We have some more podcasts prepared for you, and of course, check us out in the next tech events. The first one would be on the 8th of March, where we have the International Women's Day Initiative and the Tech Conference Series Spring Edition in 30 and 31st of March. So we're preparing stuff. Thank you, Felix, once again, and thank you everyone for joining in.
Thank you guys. Thank you, Alex. It was great being here. Have a great day. Thank you.
Thank you for joining. Be sure to check back next week for the next Hipther Talks and subscribe on Amazon Music, Overcast, Spotify, Google Podcast, Apple Podcast, iHeartRadio, SoundCloud, Mixcloud, and Pandora.